Hello there, so this is Soradeep from devdotcom, and today we are going to solve something new, something easy from LeetCode, which is the problem 217 contains duplicate. It's an easy problem, so let's see what the question is. Given an integer array nums, return true if any value appears at least twice in the array and return false if every element is distinct. As you can see from the example, see here is the example 1 2 3 1. See, 1 has been repeated twice, that's why the output will be true. If there was no repetition, there is no duplicate, the output will be false. As you can see from the second example 1 2 3 4, there is no repetition, no duplicacy, therefore the return is false. And same for example 3, you can see that 1 has been repeated 3 times, and that's why this array contains duplicate, and that's why we are returning true instead of false. Let's begin by forming the logic. What can be the logic? So let's open OneNote and let's start drawing. Let's start drawing. So we will be solving today contains duplicate. This problem, it has been given that if you're given with an array 1 comma 1 comma 1 2 3, if it contains any duplicate element, then the return will be true. If it does not contain any duplicate element, the return will be false. So contain duplicate, one second. Does not contain duplicate. So the thing is, what approach you are thinking of? One approach can be, let's at first start with the brute force approach. First is brute force. So in brute force, what you can think of, the first approach you are coming with the mind in your mind, that is you are iterating in two for loops, one inside another, and checking whether one element has been there or not. For example, in this array, let's take this 1 1 2 3 4. Okay, let's take this, and you are taking this, and you are then traversing, you are taking this and you are then traversing this whole array. You have there is already 1, and therefore you are returning true. There is a repetition, and same likewise this array 1 comma 3 comma 4 comma 4, and this you are taking 1, and therefore after you are checking with every element inside the second for loop, and if it equals or not. If it is equal, then you are returning true or else false. Same goes for this 3. You are taking 3 and you are checking for this array. But the problem here is you are taking two for loops, one inside another. You are taking two for loops, one inside another, and there is a problem. The problem is that the time complexity is big of n square, as you are taking two for loop, two nested ones. That's why the time complexity is big of n square. And that's a problem. TLE will come and you cannot submit the solution. So what can be another optimized approach? Another optimized approach can be, so let's look at the second approach, that is at first sorting the array. Why not sorting the array? Sorting the array, why? You will say, why? So why we need to sort the array? Let's see by taking an example. For example, 1 2 3 3 4. Okay, 4. Okay, and then after sorting, this has been sorted actually, no need. Actually, let's take just a random unsorted array 3 4 1 1 2 and I guess 9 8 8. Okay, if you sort this array, or just the 8 is not there, actually just swap 8 and there is 1, and if you just sort this array, what will become, because you are checking whether the array contains duplicate or not. If you sort this array, the array will be transformed into 1 2 3 4 8 comma 8. That's it. you are transforming the array into a sorted one, and then after that you can check that the next element, whether the next element is same or not. See, for example, here 8's next element is 8, and therefore you are returning true. It can be done, and therefore what is the time complexity? Because you are using a sorting algorithm, the time complexity is big of n log n. That's the thing. So here is another approach. Let's at first code this up, and then look at the third approach, and there is also a fourth approach. At first let's code this sorting approach one time, and then let's move forward to the next approaches. Okay, let's start. At first let's sort this nums dot begin and then nums dot end. The array has been sorted. Let's not put in a space there. The array has been sorted, and then what can we do? We can do the basic thing. That the basic of the basic is that let's create a for loop to I equal to 1. Then move the for loop to nums dot size 1, and then I plus plus. Inside that let's check whether the next element is equal to the previous element or not. That's it. If it is equal, then we will be returning true, else false. Equal nums I minus 1. That's it. And if the for loop has been completed, all the iterations of the for loop has been completed, then after that we can do is return false. That's it. Yeah. So you may ask why we are doing this. See, why we are starting I equal to 1. Why we are starting from 0? Why not from 0? Why from 1? You will be asking that. And the other thing you may ask is that why not equal to nums of size? We will answer. First of all, the nums of size will return, for example, this array 1 2 3 4 5 6 7 8 9 10. The thing is the thing is say it will just return the length, and we will be just iterating length minus 1. That's it. We will be returning the length minus 1. That's it. We are using less than, not less than, equal to and then I equal to 1. Why not 0? Because we are checking I equal to I minus 1. That's why we are taking from 1, not from 0. And if you are taking from 0, there will be a problem. What problem? I must say that see, for example, if I take from this position 1 2 3, if I am taking this zeros value, zeros indexes value, and then compare it to the next element, there will be a problem. What will be the problem? That after checking this, and then we will be checking this, we will be comparing this with this, and then with this, and then this with this, then this with this, and then there may have been scenario that we are comparing 8 with the element that is not existing. Of course, for that we can just reduce the loop one time, and that will be solved again. But instead of that you can do again this taking this and then comparing with this or the previous element. That can also be done. Both are okay. For now I am doing this. You can try doing the first approach that I have told, but I have not coded it up. So the second approach has been done. So let's just run it and let's check whether it is done or not. So the solution is expected. Let's submit it. Okay, yeah, it has been accepted. And then let's move on to the next approach, the third approach. What will be the third approach? So you can take a set. Yeah, set. What is a set? Set contains unique and distinct elements. Yeah, that's it. every element will be distinct, and from this array, from the given array, for example 3 4 4 1 2, from this given array you will be turning this to a set, and then what can you do? If the length isn't equal, after you have turned this array into a set, if you form a set, what will be this 3 4 1 2? If the length are not equal, then therefore return true. Yeah, if the length aren't equal, then therefore it means that it contains the original array contains duplicate. That's why the equal the length is not equal. That's it. Now if you are turning this array into a set, and after converting you see that both the arrays length are not same, and therefore you are returning true, because in set every element is distinct and unique, and therefore there is no repetition, and that's why you are returning true. Let's code this third approach. What will be the time complexity? Before coding, let's discuss the time complexity. Obviously it will be big of n. It will be big of n because you are forming a normal set, and you are traversing, you are using only one for loop, no sorting required, and therefore it is big of n. Let's code it up and to understand it better. Now dot set. Num set number begin dot begin. So it has been done, and then return the length. Yeah, let's done using num set dot size. If the original is greater than return false, or else return true. If the original is if the original is greater, the original length is greater, return true, else false. That's it. Size. Let's see whether it works or not. Yeah, it has been accepted. Let's submit it also. Because you are forming a set, here no loop is used actually, because you are forming a set with the nums, therefore the complexity will be big of n. You can see, yeah, you can analyze complexity and see it is big of n already. Okay, this is the second approach. So what about the third approach? Okay, so the fourth approach. So what is the fourth approach? The fourth approach is that you are given with the original array. What can be the original array? One. Let's take an example. 1, 2, 3, 1. This is an example of the original array, and from this original array you are forming a set. Let's at first take 1 from here and push it here, and also then before taking 2 you are comparing whether this element is there in the set or not. 2 is 2 in the set? No, and then you are taking 1, 2, pushing it here, taking 2 and pushing it here, and then you are taking 3 again, and checking whether this 3 is contained in this set or not. It doesn't contain, and then again you are taking 1, and then checking whether 1 is there in the set or not. It is there, therefore return true. If it is not there, therefore return false. That's a simple algorithm. What will be the time complexity? The time complexity will be big of n, as I will say there will be a single loop, single iteration. That's why it will be big of n. And let's code things up to get a proper and clear understanding. Let's take another set. And then let's traverse things up. and then if, and while traversing you will be taking n and then checking whether it is existing in the num set or not. That's it. Num set dot find num set dot find n, and then you are checking whether it is there or not. Num set dot end. So what is this? What is this condition? This condition is stating that if num set dot find n, yeah. So we have written this code. So what is this if statement? What is the condition inside the if? So we are checking that if the element which we are traversing using this for loop is there or not. If it is there, then see, there will be two things that will be returned. One is if it is found, then it will be the position using this num set dot find method. It will be returning two things. If it is found, then position in the iterator. If it is not found, then num set dot end. In maximum cases, which what it will be, it will not be found now, and therefore we will be checking not equal to num set dot end. If it is not equal to num set, then it will be inside the if. If it is not, then it will skip that if. That is the thing now. For example, this 3 we are taking and then comparing with 1 comma 2. Is there or not? It's 1 comma in the set, it is not there. If it is not there, then it will be returning num set dot end, but it is then we have to skip this if. Therefore we are taking not equal to num set dot end. If it is not equal to, then we have to skip that if, and if it is already in the set, then it will be returning the position of the iterator, and therefore it will be not equal to num set dot. It is not returning num set dot end, therefore it will be inside this if. That's it. And then sorry, it will be there t, and then num set dot insert, and if it is skipped, then we are inserting successfully, we are inserting that element in the set. Okay, and then after the for loop we will be returning as usual. If it is if the if has been skipped for all the elements, then normally it is not, the array does not contain any duplicates, therefore it will be returning false. That's it. Let's run it. Yeah, it has been accepted. Let's submit the solution then. Yes, the solution has been submitted. So time complexity, as you can see, the time complexity will be big of n. As you can see that the loop, there is only one loop and it is iterating for n times, where n is the size of the array, and therefore moreover it will be the big of n, and that's the time complexity. Okay, so thanks for watching up to this. If you are still there, thanks for watching. In the next video we will be solving the next LeetCode problems, and we are planning to create. Thanks for watching. Let me write this at first. And we are planning to, at devdotcom we are planning to create a playlist containing 150 LeetCode questions, such that it will be benefited in the respect of problem solving. You will gain problem solving in the respect of interviews. We are planning to do such. Let's see how it goes. And thanks for watching. Hope you like this video. If you like this, click on the like button. If you want to subscribe our channel to follow for more tech content like this one. We will not be giving out LeetCode solutions, but apart from various videos will be coming regarding regarding various domains in tech, for example machine learning, web development, Android development, and many more. So hit that thumbs up, hit that subscribe button if you want to follow us for more videos. And thanks for watching. Bye bye. We will meet you in the next video. Bye.